The next type of platform which comes into play is compliant type platform. Compliancy is a term related to flexibility, movement. So, friends, the design concept of offshore structures moved from strength based to compliant based. That is, instead of paying attention to stiffness, people paid attention to flexibility. They made the system design compliant, freely respond to the loads. So, now the loads are encountered not by strength, but by displacement. Now, displacements can be of two types. Which happens at the member level, which happens at the structure level. So, this is global, this is local. This is otherwise called deformation, this is otherwise called rigid body motion. So, compliant structures are designed to have large rigid body motion. So, the strength is replaced by deformation characteristics. Okay. So, compliancy induces flexibility to the platform. So, this is verified by various studies available in the literature, Chakravarti 1990, 1994, etc. Now, as they become flexible, response to counteract environmental forces by undergoing large displacements. So, they undergo large displacements. The moment I say they undergo large displacements, then it happens in different degrees of freedom. Let us take 3 axes, x, y and z for any body in space. It has free displacement on all the 3 axes, surge, sway and heave. These are displacement degrees of freedom along x, y, z axis respectively. Now, put your thumb towards the arrow of your right hand, remaining 4 fingers of right hand will show you an arrow direction. Okay, you mark that direction. That is called roll about x axis, pitch about y axis and yaw about z axis. So, there are 6 degrees of freedom. Three translational, 3 rotational. All are rigid body motion. The whole system displaces in this style. So, amongst the 3 translational, surge and sway are kept to be highly flexible. It means they will have large periods, they will undergo large displacements in surge and sway, but heave is restricted. Similarly, in 3 rotational, when surge and sway are free, rotation about surge axis and rotation about sway axis, that is pitch and roll, are restrained. Since heave is restricted, rotation about heave, that is yaw, is free, is flexible. So, the platform has permitted of large displacement in surge, sway and yaw. They have restricted displacements and rotation. I should say motion, large motion and rotation in heave, roll and pitch. So, friends, compliant structures restrict or restrain loads by displacements, but please note, not on all degrees of freedom. So, systems which has 2 band of degrees of freedom, that is stiff and flexible. Stiff will have very small periods, flexible will have very large periods. For example, surge, sway and yaw. Small periods will have roll, pitch and heave. Are combined in single platform. Such platforms are called hybrid platforms. Hybrid because 2 bands of frequencies or periods which are either very large or very small are combined on the same design, and such designs are called hybrid platforms. So, compliant structures restrain loads by displacements, not essentially by their strength, but the flexibility which refers to compliancy does not happen in all degrees of freedom. Certain degrees of freedom are restrained in motion, but certain degrees of freedom are highly compliant and flexible in motion. So, such a unique combination gave rise to new type of structures, they are called compliant structures. So, compliancy refers to flexibility, they have flexibility in rigid body motion, but please note, not on all degrees of freedom, only on few degrees of freedom. Okay? So, now the question comes, when such compliant structures are to be installed for oil exploration, they should be position restrained. How it is achieved? So, let us take a simple floating body, of 3 diameters. Okay. The floating body has a water level up to this. The floating body has a weight which will act through the CG of the body. The displaced volume of the body will also give an opposing force to that of weight, which is called buoyancy force. So, now weight and buoyancy force are opposite each other, they will be concurrent, about CG, coplanar, but the design of compliance structures is buoyancy will exceed the weight. It means the tendency is always to push the body out of water or above the water level. So, what is the use of such kind of design philosophy? It is interesting, if you have a system whose buoyancy is much larger than the weight, the body will freely float. Once the body freely floats, it is easy to install the body. You do not require special type of cranes, etc. The body will freely float. Now, how to restrain this motion? You have got to connect this body to the seabed, but not resting the body on the seabed. So, to connect this body to seabed, one can use cables, wires, ropes, they are all called as tethers or tendons. There are varieties of compliant platforms which are constructed concepting what we have just now discussed. So, let us see them in the next lecture. Let us see what is the summary we have learnt in this lecture. We understood that the gravity based platforms, the jacket platforms, which are essentially fixed type platforms, resist loads by their strength. They have certain merits and certain demerits, which makes them non-suitable for larger water depths. As we go towards increase in water depth, people preferred semi-compliant structures. Jack-up rigs came into play, but they are not meant for deep waters, they are meant for shallow waters. Now, to perform oil exploration and drilling in deep waters, researchers started using compliant structures. Compliant structures resist loads by displacement by and large and not by their strength. So, interesting friends, strength is not considered as a design parameter, whereas displacements are considered. So, in the next lecture we will talk about different types of compliant structures and the merits and demerits and the response behavior under wave loads, and then we will come to a better understanding how offshore platforms are conceived from the fixed type to a completely a floating type as of present today. Thank you very much.